Good afternoon. So today we're going to talk about using our Swifty for the objectives, for the stringly typed API. So what is the stringly typed API? According to the internet, it's a riff on the term strongly typed. So it's used to describe an implementation that needlessly relies on strings when programmer and refactor-friendly options are available. Two examples. So one is the stringly type. So if you've worked with UI image initializer, you know that it takes a string, and that string corresponds to like something in your resources. Whereas the UI table view initializer uses an enum, so you can only instantiate it with a plain or a group style. Are there any downsides to using stringly typed APIs? Yep. Let's go through a few of them. So first things first is that when we're left to our own devices and we don't have the precompiler, such as like when we write out strings, we tend to write a lot of typos. So one I always do is I always misspell the word notification. Another one is side effects. So here we have our UI image initializer again, but I've actually misspelled my word Charmander. So that's a side effect because it can return an optional, or it can return nil, sorry. And another one is collisions. So let's say we have user defaults. So part A of our app is setting is user logged into false, and then part B of our app is setting is user logged in to true. And when key A, those two different parts of the app don't really know about each other, but at the same time they're saving different values to the same key. So then you could get unintended side effects from that. Runtime crashes. So anyone here started off before iOS 5? Yeah, cool. So table views, before iOS 5, we had a different, we didn't have to register a class, but when iOS 5 came out, so when we want to display a UI table view cell, we'd have to register the cell and give it a reuse identifier. So in the boilerplate code when you create a UI table view controller is cell identifier. So then we go down into our UI table view data source function, and we have a DQ reusable cell with cell identifier. And here I've actually misspelled cell identifier. I've actually missed out an L. So that's actually going to cause a runtime crash, and nobody wants that. Another one is Unicode Artifacts. So if you copy strings from unsanitized sources, such as like rich text editor or iMessage or whatever, you can actually bring stuff into your source code that at first glance, it looks like nothing, So here I've actually put an emoji here, but in Xcode, it actually appears like there's nothing there. But the good thing about this is this only affects Objective-C. Swift precompiler tells us, hey, you had this illegal character, you should fix it up. One of the things I disagree with stringly typed is that they're disorderly. So here we have, tilde casing versus camel casing. And if you're OCD like me, this keeps you up at night. Another one is sometimes we use prefixes. Prefixes are good because it allows us to namespace our keys. So here we have no prefixing. Here we have some prefixing, so we don't get collisions. And the final one is like we might even prefix with our bundle identifier, because we would do this maybe because an external framework, we might collide with an external framework. And naming. So here we have 3 different ways to spell a key. So is user blocked, or has user been blocked. So we're mixing tenses. And they're everywhere. So UI image, UI kit is especially a big culprit of these, and then and so is foundation. So, you have UI image, UI collection view, URL, date formatter, user defaults. Today we're going to focus on user defaults. So, quick recap. What is user defaults? Well, it's used to store small persistent pieces of information. So I like to use it as settings. I sometimes like to put in small pieces of objects in there because I don't want to bring in core data. But speaking of core data, everyone knows someone or knows of someone who's actually used user defaults as a replacement of core data. That's why we call it Diet Core Data. You get all the flavor of core data without none of the performance. And unfortunately, it's stringly typed. So let's use our Swifty for a user defaults API. Before we do that, let's take a quick recap on Swift 3, because Swift 3 is around the corner, and we're all going to be clamoring to get onto Swift 3, right? Those with Swift 2.2 and below do not want to deal with Swift 3. So these are, as of Xcode 8, beta 6. So first things first, the big rename. So user defaults is no longer known as NS user defaults. So NS, for those who don't know, comes from Steve Jobs' company following Apple. It stood for Next Step operating system, which probably today we know as Mac OS. The instance. So used to be standard user defaults. Now following with the Swift API guidelines, it's just standard. And you notice that's not a function anymore. It's just a computer variable. Thank God. The set APIs are different as well. So now, no longer do we do like set bool, set int, set object. We just say set. And how do we do this? It's because with Swift, we have this little cool thing called function overloading. So you can have the same function name, same parameters, but as long as the parameter types are different, the compiler will be able to infer which API you intend to call based on the parameters you pass in. So here I'm actually passing a Boolean, so it's actually calling set bool. The get APIs are pretty much the same, except they're just following the Swift API guidelines. So you're removing the first parameter name out of the function name and into its own parameter name. And synchronize has been deprecated. Yes. All right, so we said user defaults is stringly typed APIs. Here's what they look like in Swift 3. So let's start with fixing them. First things first, if you write a string more than once, you should just turn it into a constant, right? So this helps us avoid typos, and it just makes our code a lot easier and neater to read. Cool. Simple. Step 2, one pattern we brought from Objective-C is sometimes we like to unify things. So here we have this struct constants, and we have a substruct called keys. So we do this so we can have a bird's eye view of all our constants and helps us maintain uniformity. So now, when we interact with user defaults APIs, it looks like this. So, user default standard, set true, for key constants, keys, is user logged in. But then, as you noticed before, we use comments, so why don't we just use a sub-substruct called account? So static let is user logged in. It's a static because we don't want to initialize the sub-substruct every time we want to use the key. So now it looks like this. User defaults, standard, set true, for key, constants, keys, account, is user logged in. So we have this problem here where we have this sub-substruct account. I'm just going to call it struct account. So we have this struct account, and you can see it is let is user logged in equals is user logged in. So once again, this is prone to errors because it is and it isn't. Like if you're OCD, it is. Because if I misspell is user logged in with an extra N or whatever, and that makes its way into production code, and I find out about it a year ago, I'll just hate myself. So what I'd suggest is switching to enums. So why enum? So here you can see we have an enum account which conforms to string raw representable. And instead of a static let, we use a case. Case is user logged in. The cool thing with enums that conform to string raw representable is if we don't provide a value, its value will be the same as its case. So when we use it, it looks like this. A little bit different, a little bit nicer, but yeah. And then we go to user default standard, set true, for key, constants, keys, accounts, is user logged in, raw value. Let's do a recap. So first we start off with strings, then we turned them into constants and we grouped them together. We gave our string path, or our constant path, a little bit of context, so saying constants, keys, accounts, is user logged in. And we added that little bit extra safety by turning it into an enum. So constants, keys, account, is user logged in, raw value. The problem is with this. It started out so simple, with a simple string, and because we're paranoid, and because we OCD, it ends up like this. And using it in code really hurts. So what we're going to do today is we're going to extend user defaults. Cool, right? Cool, so we went from squirtle to wartortle. But we can go better. This is what we want. So we're going to extend user defaults. So I know it's pretty late in the afternoon. Everyone's been sitting down. So I'm going to give you a little bit of a taste of what we're going to do today. So we're going to turn our code from this to this. And how are we going to do this? So if you've been writing Swift, or you know someone who's been writing Swift, and you ask them to solve a problem, their one answer for everything is protocols. So what does our protocol look like? Well, it's going to be called bool default settable. So protocol bool default settable. As you can see, it takes an associator type called bool key, which conforms to raw representable. But before we get into the gist of it, let's go back down memory lane to WWDC 2015, where we introduced to Krusty. It wouldn't be a Swift conference without a mention of Krusty, right? So, a lot of you know Krusty, but what a lot of you don't know is Krusty's third law. For every protocol, there's an equal and corresponding protocol extension. So yeah, following Krusty's third law, we have a protocol extension. As you see, we have a where clause in there. So where boolkey.rawValueType is equal to string. Okay, we're going to do it. So now we have our setter. So pretty much the exact same API as user default. So func set value boolean for key and pass in a bool key. And then we have a let key equals key.rawValue, and we just use that raw value to set the value and key to user defaults. Same goes for the getter. We have func bool for key, takes in a bool key, returns a boolean, let key equals key, return user default standard bool for key, key. And an overview, it looks like that. It's pretty simple. So here we did bool key, but you could do the rest of the default settable family. So integer, double, float, object, URL. All right, so then now we're going to extend user defaults, right? So user defaults now extends to conform to bool default settable. To do that, we have to include our associator type. So in our case, it's bool key. It's an enum, which conforms to string raw representable. And our first case is user logged in. And this is what it looks like. So much nicer, right? Cool. But because we created a protocol extension, a protocol, doesn't mean we're confined to user defaults. So if you want to add a little bit more context, we extend other objects. So in this case, it's account. So it's better looking at account set true for is user logged in as opposed to user default set true for is user logged in. But now we have this collision problem, right? So account bool key is user logged in is the exact same as user defaults bool key is user logged in. So we're going to make another protocol. This protocol is called key namespaceable. It's one simple function, takes in a generic, so a generic which conforms to raw representable, and returns a string. And once again, we follow Krusty's third law. We extend it. So it's pretty much a simple return string. It's using string interpolation. So combining the string version of self and the key.raw value separated by a full stop. So in this case, it will be user defaults is user logged in. And then we go back to our protocol bool default settable. We make it conform to key namespaceable. So yeah, back to our setters and getters. You see here we have let key equals key.rawValue. Well now, because bool default settable conforms to key namespaceable, we can just say let key equals namespace key. So I'll show you again. Key.rawValue equals namespace key. And now we're collision free. So what about uniformity? Well, the cool thing with Swift is that when we extend a class or extend an object, that extension doesn't have to live within the same class or the same Swift file as its declaration. So we go back to our constants.swift pattern, and we can just put our extensions in the constants.swift file outside of the constant struct. And we do this so we can have a bird's eye view of everything, everything we've, all the keys we've used within our app, depending on their importance or whatever. And they work just the same. So what about context? So before, instead of using user defaults, set true for user logged in, we moved to account set true for user logged in, and that brought us more context. So instead of sticking with the constants pattern, what I would suggest is actually making a default. So we have a struct called default, and we have some substructs called account, onboarding, whatever. And when we use it in code, we have uniformity, we have context, and it's actually a lot easier to read than what we started with. So yeah, now we're well on our way to become Swift Pokemon trainers. What have we learned? Stringly type APIs are bad. You shouldn't really use them, but yeah, just don't use them actually. There's plenty of room for improvement with our code. We should always be challenging the ways of the norm and trying to explore what we can do and what we can't do. Grouping constants isn't a necessity, but at the same time, I like to do it because I like to maintain uniformity in whatever I'm doing. Namespacing our APIs gives a lot more context, as well as with our strings or with our keys, it helps us avoid collisions. Protocols are so hot right now. Hashtag Magatu. And then finally, we should rethink how we work with APIs. Just because we have these APIs given us by Apple, the gods at Apple, and their strings, doesn't mean we have to use them the way they were delivered to us. They give us stringly typed APIs because it's the way they can help us cover all bases, all opportunities of what we want to do. They can't give us an enum for defaults because, unlike a table view, they cannot predetermine what we want to do with our code. So I'd like to think of it as like you have a house, you start moving in, but at the same time, you want to get rid of all the old furniture and maybe just start putting in your own. Thank you very much.